Hi, everyone. What I want to do is go over collected homework 3. Again, the scores are a little low, median of a C about. Yeah, anyway. All right, let's go over it. So let me do the first problem. Just get my digital pen connected. Okay, so really there's, I guess, two kind of ways to do this. You can find how much is in the account after 20 years and then work from there. I'm not sure if that's really the best way to do it. I mean, it's a fine way to do it. It's just the way, you really need to get used to not thinking that way when we do annuities. I mean, if you really think that way, like find how much is in an account at the end of each period. When we do annuities, you're going to have lists of numbers that are literally like to have, hundreds of columns, and I'm not going to look at that, absolutely. And in the past, I haven't said officially I won't even look at things like that, but I'll make an announcement. I won't even look at PowerPoint stuff or lists of tables of numbers like I have in the past. But anyway, okay, so let me draw a time diagram. Okay. Yeah, not too many people are drawing time diagrams. Trust me, you'll need it soon. Okay, so for the last 20 years, we don't know what the effective annual interest rate is. For the first 20 years, let's figure it out. All right, so first of all, I'm giving you not I12 is 0.04, D12 is 0.04. Okay, so we use our formula for D. I'm not discussing a difference here. That's kind of the whole point of that video that I made. I forget which one exactly, but anyway, so use the formula for D. And then dump in for I. It's D over 1 minus D, so 0.03927 over 1.03927. This is a 7. 0.04088. Okay. Okay, so sorry, it's 100 now, 120 years later. Right, so 100 for the first 20 years accrues 20 years of interest at this interest rate, and then accrues 20 more years of interest at this unknown interest rate. That's the first 100. Second 100 just accrues 20 years of interest at this unknown interest rate. Yeah, so even if you did not do the problem this way, it's very important to understand this, how I'm doing it. Okay. And we're given this is going to be equal to 700. So I trust you can solve for I. You do this, you get I is 0.03945. So plug into your formula. D is I over I plus 1. Sorry, actually here I screwed up a bit. 1 second. So I is D over 1 minus D. So it's 1 minus 0.03927. That's 0.04088. Sorry about that. Yeah, I'll make a comment in the YouTube video that I screwed up a little bit. Anyway, so D is I over I plus 1.03945 over 1.03945. So the whole point of this problem is really, getting, you getting used to nominal interest, nominal discount. So 0.03795. Finally dump into the formula for D52. 52, 1 minus D, 1 over 52, 0.03867. Okay, so that's D52. All right, so number 2, and I got very strange answers. People mixing up the deposit of X and the deposit of 100. I have no idea why exactly, but anyway, I'm not sure. Not gonna speculate on why, but anyway. Yeah, so all right, so let's say A of T is the amount after T years from the X deposit. So A of 5, remember this is from the X deposit. This is made at T equals 0. So it's X is A0, A0, the initial deposit from the X deposit. So it's 0 to 5, delta T dt. So this is X e to the, 0 to 2, 0.02 T T. Someone had multiplication. It's plus here. That's how you break up integrals. You add them. You don't multiply them. 0.003 T squared T. So it's going to be 0.02 T squared over 2, plug in 0 and 2. 0.003 T cubed over 3, plug in 2 and 5. So it's 0.04 plus 0.117. That's 1.17 X. Check that. Round it off oddly here. Yeah, you get a lot of 9s. So you round to the nearest 5 decimals, you do get 1.17. Okay, so if B of T is the amount after 4 years from the 100 deposit, well, you deposit 100 at T equals 4, and we're going to T equals 5. So this is 100 e to the 5 0.003 T squared dt. 100 e 0.003 T cubed over 3. Plug in 5, plug in 4. And this is going to be 106 to I'll just write this. Want to check your answer. 100 e to the 0.061. That is 106.28989. So add these up, they have to be 350. So 350 is 1.17x plus 106.28989. X is 20830. Okay. And if you want to do it the other way, I guess I'll do that real quick. Yeah, I don't think either way is really better for number 2. But right, so after 4 years, how much do we have? Well, it's X e to the integral 0 to 4 t x again, just do this quickly, 0.02 t squared over 2 0 2, and then 0.003 t cubed over 3 2 to 4. I have to do the other one in my calculator. Did not do that yet. So this is 0.04, and let's see, 4 cubed minus 8, 56. So this is going to be 0.056. So 1.10076. Okay. So after 5 years, this is how much we have after 4 years from this deposit X. So we add 100. Sorry. Let's not get ahead of ourselves here. So yeah, this is before the deposit. So I mean, this kind of, yeah, this way is a pain in the ass, I think. So I'm not sure if it's a really good way to do it. Okay, so after 5 years, it's 100 plus 1.10076. Sorry, I forgot the X here. E, and we did this integral already. Oops, sorry about that. So it's going to be 100 plus 1.10076x times e to the 0.061. 0.061. One hundred plus 1.076x times 1.0628899. All right, so Let's just get that. So it's 106,2899. Plus 1.169, 1.17, sorry. And this whole thing has to equal 365. 365, the hell am I talking about? 350. It's got to be, we're given that this equals 350. That's exactly what we had before. So actually 1 second. Yeah, I think prior this was an 8.9, but it's basically the same thing. So yeah, take this, solve for x. Same answer. 20830. Okay. Yeah, so got some funky integrals here. But okay, so for fund A, it's A0, 100 e to the integral 0 to 3 delta t dt. So it's 4k t dt. You can either pull out the 4k or just integrate this, doesn't matter. I guess I'll pull out the 4k. So it's t squared over 2. 0 to 3. And this is going to be 100 e to the 18k. Okay, so fund B, so for fund B, again, I'm not giving you I-365, I'm giving you D-365. So forget if I focused on discount or interest on the exam for summer 2022. But anyway, so we're given that nominal discount compounded daily is 4%. Okay. All right, so dump into your formula. D is 1 minus D 365, it's 0.04 over 365 to 365. And that's going to be 0.03921. So dump into your formula for I, D over 1 minus D. And you get 0.04081. It's 0.03921 over 1 minus 0.03921. Okay, so if B of t is the amount after 3 years, so let's get B of 3. Sorry, if B of t is the amount in fund B after t years, I don't know if I said 3 or t, a long day. So it's 1.04081 cubed. That's my effective annual interest rate. So 3 years. That's my effective annual interest rate corresponding to nominal discount compounded daily. Okay, so what do we have? We have 100 e to the 18k is 112,74943. K is 0.00667. Okay, last but not least, so not too many people did this correctly. I did give a hint that you should watch the video that I made on how to do this problem. But anyway, all right, so one. So this is going to be 0.013 squared is 0.09. So we have 9% growth per year. Okay. Now remember, what do I mean by this? And this is in stark contrast to effective annual interest. So it's really like it's actually kind of like a simple interest rate, essentially. So when we do this, I mean that if I have 9% growth per year, then to get the growth for 2 days, it's going to be 9% times 2 over 365, which is what is this? It's slightly differently on my solution sheet, so just bear with me. This is going to be sorry. Point 0.049315% growth per 2 days. Okay, so that means if we're growing by this much per 2 days, then 2 days after 3 years, 2 over 365 is approximately, remember this is just approximate, that's kind of the whole point. We're in a small time interval, so this is a good approximation for percentage growth per year. It's basically the definition of force of interest. So yeah, just this is, you know, just right. Well, after 3 years, we have 20 million. Grows by this percent per 2 days. So divide by, add 1, divide by 100. It doesn't matter how you rounded. I gave you the right, gave you full credit if you, and sorry, you gotta be a little careful. There's 3 zeros. 0.0049315 times 20 million. And you basically get 20,000,986.3. Right. Okay, so exactly A of 3 plus 2. So this is exact. So it's how much we have after 3 years. 0.01. Okay, so that's going to be 0.01. T cubed over 3. Plug in these. 20 million. E to the 0.000494. So again, doesn't matter how you rounded. Yeah, so you get 1 second. That. So you get 20 million 098. Sorry. 0098. Um, 8244. Okay, so yeah, so we're off by about $20. So relative to $20 million being off by $20 is pretty damn good approximation. So right. So again, just this is what we mean by percentage growth when we're dealing with relative rate of changes. That's just the way relative rate of changes work. And the force of interest approximately gives you the relative rate of change at this time, t equals 3 years, over a very small time interval. 2 days out of the year, 2 over 365 is pretty darn small. It would be an even better approximation if it was 1 day or 1 hour or 1 minute. Kind of curious how close it would be after 1 minute now, but anyway. All right, good luck on the exam. It's due Sunday. Maybe this helps. I am hoping more people watch this video than the homework 2. But anyway, all right, so long. Take care. Good luck. Have a great weekend. Bye-bye.